In the next two lectures, we are going to learn the trigonometric functions. There are 6 trigonometric functions, and they are defined as the ratio of side length of a right triangle, or as the ratio of coordinate length on a unit circle. Let's start with a unit circle in this lecture. A unit circle is a circle with radius 1, and it is in standard position. Standard position means the center of the circle is at the origin on the Cartesian coordinate. So on an xy plane, the center of this circle is at x equals to 0 and y equals to 0. Then let's define the initial edge that is lying along the positive x-axis. And we have a terminal edge that also leads from the origin. So we can define an angle that is between the initial edge and the terminal edge. And in convention, the angle is defined as positive angle when we leave from the initial edge counterclockwise. So as shown in the first graph, this angle is a positive angle. And we could also have a negative angle, then we'll leave from the initial edge clockwise to the terminal edge. Then this angle will be a negative angle. Now let's consider the circumference. What is the circumference of a circle? The circumference of a circle is 2 pi r, where r is the radius. So what would be the circumference of this unit circle? Let's denote the circumference as c. The formula is 2 times pi times the radius. But since it is a unit circle, so the radius equals to 1. So this equals 2 times pi times 1. Pi is around 3.14, so 2 pi is around 6.28. But since this number is an irrational number, it is very hard to remember this, 6.28, 3185. So we are going to use another unit to measure the angle. Instead of 6.28, I'm going to use 2 pi for the circumference of this unit circle. And we call this unit radians. So it is also a unit to measure angle, just like the degrees. For one circle, which is 360 degrees, that equals to 2 pi radians. Let's do some practices using this new unit. So we learned that for a circle, which is 360 degrees, that corresponds to 2 pi radians. And for short, I'm going to write radians as rad. So half of the circle, 180 degrees. It corresponds to pi radians. How about a quarter of a circle, 90 degrees? 90 degrees would correspond to pi over 2. So degrees and radians are all measures of angles, so they should be interchangeable. Let's look at these two examples. The first one, I want to convert 45 degrees to radians. Then I can use the ratio to find the angle in radians. Since I know that 2 pi radians corresponds to 360 degrees. So this ratio should remain the same if I change the degrees to 45 degrees. So this should equal to x radian divided by 45 degrees. Then I solve for x. X equals 2 pi radians times 45 degrees, then divided by 360 degrees. And this equals pi over 4. So 45 degrees also equals to pi over 4 radians. How about if an angle is given in radians and you want to convert that to degrees? We can use the same approach, so we use the ratio. We know that 2 pi radians corresponds to 360 degrees. So 2 pi divided by 360. This ratio should equals to pi over 6 radians divided by x degrees. Now I can solve for x. X equals 360 degrees times pi over 6 radians and divided by 2 pi radians. And I get 30 degrees. This figure shows some important angles in radians on our unit circle. In the first panel, we have 0 degrees, 90 degrees, which is pi over 2 radians, and 180 degrees, which is pi radians, and 270 degrees, which is 3 pi over 2. Then in the next panel, we have 45 degrees in each quadrant. So they correspond to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 radians. Then the next panel, we have angles that are 30 degrees and 60 degrees, so they are pi over 6, pi over 3, and so on. And remember I mentioned that we could also have negative angles. When we have negative angles, that means we are going clockwise from the initial edge. For example, if I have negative pi over 4 radians, that means I leave from the initial edge, which is the positive x-axis, and I go clockwise pi over 4 radians. Pi over 4 is also 45 degrees. That means the terminal edge is this. So this angle also equals to 7 pi over 4 radians. We can also consider angles that go more than once around the circle. For example, 5 pi over 2. I can rewrite 5 pi over 2 as 2 pi plus pi over 2. That means I'm leaving from the initial edge. I go one round around the circle, 2 pi, then I have an extra pi over 2. So 5 pi over 2 radians also equals to pi over 2 radians. And that is the end of the lecture. A unit circle not only tells us a new unit to measure angle, but the ratios of the coordinates on the circle will also tell us a value from a trigonometric function, as we'll learn in the next lecture.